Okay, now, since I don't want to waste class time just doing nothing, I'm going to start on some next semester material. So when we come back for break, after Christmas break, I'm going to want to hit the ground running on this. Maybe take an assessment fairly soon over it after Christmas break. Now, this first standard is crappy, okay? Not a lot of application. The next standard's awesome. That's got a lot of good stuff in it, but not this one necessarily. Okay, I've made you out a root sheet. It's called a radical sheet. You need to rip that off and let me explain what it means. Perfect squares. This is the same thing that's on the board. Now you have your own sheet. These are my perfect squares. The reason they are is because when I square root those, they equal a nice solid integer, or whole number actually. These are perfect cubes, okay? You're going to start hearing about perfect cubes. 1 times 1 times 1's 1. 1's a perfect cube. 2 times 2 times 2's 8. 8's a perfect cube. And you're going to start seeing, instead of just square roots, you're going to start seeing cubed roots. So when you see the cubed root of 8, what they're really asking is what times what times what is 8? It's got to be the same factor, and that's 2, okay? The cube root of 27 is 3, because 3 times 3 times 3 is 27. These are all perfect cubes, as you can clearly see the pattern here. So if you finding the cube root just takes you back to the fact you're multiplying. Now here's the thing. Square roots we know can be positive or negative, because 3 times 3 is 9, but so is negative 3 times negative 3. Okay? That's why 9 is actually positive negative, so it could be negative as well. Now, cubed roots are only positive, and here's why. If you take 2 times 2 times 2, that's 8, but is negative 2 times negative 2 times negative 2 8? No, it's negative 8. So that's why the cubed root of 8 is only positive. It's only positive 2, okay? All right, now we also have perfect force. Not as many, it goes on forever, but I have enough. I have all we need. Okay, so that's 1. The cube root, the fourth root of 1's 1. 2 times 2 times 2 times 2 is 16. So in addition to being a perfect square, 16 is also a perfect fourth root. The fourth root of 16 is not 4, though. What times what times what times what 16? It's 2. Okay, you don't need to memorize this sheet. Okay, I'm using it on tests, whatever. 81, it's a fourth root, but it wouldn't be 9, because what times what times what times what's 81? It's 3. Now, those could also be negative. So let's take something like 3 times 3 times 3 times 3. It's 81. But negative 3 times negative 3, if you calculate that, that's also 81. So therefore, the cube root of 81 is 3, but it could also be negative 3. Now, fifth roots. These are all your perfect fifths. 1, 32, and that's about all we need. That's really all the higher we go. Okay, so if I see a fifth root of 32, it's 2. Now, I got to decide if it's positive or negative. $32. Now, if I make all these negative, am I still going to get 32? No, I'm going to get negative 32. So, this is only positive 2. It's not negative 2. You ever notice a trend here? Anytime the root's even, it could be positive or negative, but anytime it's odd, it's just positive. Okay, now here's what I'm asking you to do here. Okay, now here's the deal. It's not really all that fun, but I kept the assignment short, so no complaining, please. I don't want to listen to it. Okay, what kind of a root is that, first off? Well, if I don't see anything, I assume it's a square root. And 9's a perfect square, okay? Sure it is. It's 3, okay? But it could be plus or minus 3. Okay, 98. 98. Square root, so 98's not on the list, so what I do is make those 2 roots. Now, if I try dividing 98 by 81, it won't work. 98 divided by 64. Won't work. Okay. 98 divided by 49 work. Whoops, sorry, 98 divided by 49. Okay. Okay, so I divided it by 49. Now what was 98 divided by 49? 98 divided by 49 is 2. Okay. So the square root of 49 is 7. And I put square root 2. Now again, that's a square root, so it could be positive or negative 7 square root 2. Okay, next up, now we're doing a cube. So now what I need to do is look at perfect cubes. 27's on the list. Okay, the cube root of 27 equals 3. So I'm just going to put 3. But it's only positive 3. Okay, because it's an odd root, so it's only going to be the positive. The cube root of 8. Okay, so I'll look here and put 8. Okay, was 2. Okay. So, because 8's a perfect cube, what times what's 8? That's what the cube root of 8 means. It's equal to 2. 54. 54 is not on my list. Okay, so I make 2 roots, but they're both cube roots. Okay, so I put little 3's there. 54 divided by, you'd start with 27, and lo and behold, that works. So I divided by 27, and I got 2. Now, the cube root of 27 equals 3. So I replace this with the number 3, and then cube root 2. Okay. Cube root of 56. Well, 56 is not a perfect cube, so I need to make 2 roots, and I put cubes on both of them. 56, not divisible by 27, but it does divide by 8. So 8, and then 56 divided by 8 is 7. Okay? So what's our cube root of 8 equal? It equals the whole number 2. Okay? So 2 cube root 7. Okay, the cube root of 15. Well, 15 is not a perfect cube, so I'm going to need to attempt to factor the root. But 15 really doesn't divide by anything other than 1, and that's kind of pointless. So what I do is nothing. I pretty much just circle that. It means it's prime. 256, that's not on the list. Okay, so I break it up. I see what maybe 256 divides by. Well, does it divide by 216? No. Does it divide by 125? No. Does it divide by 64? No. Yeah, it does actually. 64 and 4. Now we got to go look and remember the cube. It's not 8 either. It's a cube root, not a square root. So what times what is giving me 64? Looks like it's 4. So this equals 4. Okay, so I have 4 cubed root of 4. Sometimes you'll end up with the same outside and same inside. Okay, now we're doing fourth roots. So flip over this paper and let's look at our fourths. And the fourth root of 16, and 16's on the list, so the fourth root of 16 equals 2. But now we're back to plus or minus, okay? The fourth root of 81's on the list. It's 3. Now we're back to plus or minus, because fourth root says it's 3. Okay, fourth root of 80. Now 80's not on the list, so we need to factor it into 2 roots. Okay, so 80, does it divide by 16? Let's just see. Yeah, it does. 16 and 5. Okay, so what's our fourth root of 16 equal to? It's equal to the number 2. So 2, so the answer is 2 fourth root of 5. Okay, the fourth root of 100. No, it's not 10. It's not a square. It's a fourth root. Okay, so 100's not a perfect fourth, so I need to try factoring it into 2. And those are fourth roots, remember. 100 doesn't divide by any of those perfect fourths, so it's prime, okay? By the way, I screwed up. This was a fourth root. It needs a plus or minus. That's also fourth root. We put a plus or minus, even though I couldn't do anything with it. Now we're at fifth roots, so perfect fifths, okay? All right, the perfect fifth is, see, 32 is, it's equal to 2. But that's only positive 2. 162. Now, once again, if I don't see anything here, I assume we're back to square roots. Okay. So 162, not on that list. A lot of people screw this up because they don't know how to pick the right list to look at. 162 does not divide by 144 or 121 or 100. It is divisible by 81. So 81 and 2. So, because 162 divided by 81 equals 2. So the square root of 81 equals 9. So 9 square root of 2, but it is plus or minus. Okay, now you need to go work through the 8 problems and then come back. Okay, come back. Because we're not done in this packet. Do those 8 problems. Okay, now what I need you to do is the problems that ended up that could not be made into just one whole number answer, I want to teach you how to do that on the calculator as well, because that's important for you to know. So that ended up 3, so there's really no calculator to that. But when we end up with like 7 square root of 2, I want to teach you how to do that on your calculator. Here's how you do that. Okay, well, square root of 90, everybody knows that. 98, okay? So 9.90. So it could be plus or minus. Actually, these are pretty close to the same thing. That's just in a different form than that. Okay, that's a whole number, so I don't need, that's a whole number, so don't bother. Now, here's the thing, that's not, so it's a third root. Well, I don't really know how to third root on the calculator. Actually, I do, but I don't want you doing it that way. To find a cubed root, what it is, you're going to raise 54 to not the power of 3, but the power of 1/3. The power of 1/3 in cubed root means the same thing. Okay? So 3.78. Okay? So I want to see both those answers. Now again, 56, that obviously wasn't a perfect cube, so I take 56, and to find it, approximate the cubed root, I raise it to the 1/3 power, 3.83. Okay, cubed root of 15, obviously that's not a whole number, so I take 15 and raise it to the 1/3 power, okay, 2.47. Okay, take 256 to the 1/3 power. Whoops. Come up with 6.35. Okay, that's a whole number, so we're good. That's a whole number. Now let's approximate the fourth root of 80. So 80 to the power of 1/4 would be 2.99, okay? Plus or minus, so. Okay, let's take 100 to the power of 1/4, okay? It's going to be 3.16, that is plus or minus. Now let's take 35 to 32 to the power of 1/5. Or I don't, what's the point? It's already 2. Now, just square root your 162 like you normally would, and that's 12.73. You kind of need to know both ways to be successful on the standard. You got to know how to come up with that and that. So you needed to take those, the ones that did not work out perfectly on your, that were not on the list, and you had to factor them down. Now take those and find those on your calculator.